we're going to do some calculations with fractions where the fractions are algebraic, so including a variable. We're going to add and subtract algebraic fractions, and we're going to solve more complicated equations with algebraic fractions. Let's start with our first type of problem. I'm going to show you 3 types, so this is number 1. We're going to try to write this as a single fraction. Okay, you cannot add fractions that have different denominators. We want the denominators to be the same so that we can simply add them. In order to do that, we need to find a common denominator, and this is the common denominator that we can easily change this into this, and we can easily change this into this. So let's do that. To change this into this, we multiply by x plus 2. What we do to the bottom, we also do to the top, or otherwise the value of our fraction is going to change. So x times x plus 2, we multiply the bottom by x plus 2, so we multiply the top by x plus 2. Right? Now this one, to change that denominator to this, we multiply by x. So we multiply the top by x. 1 times x is x, and x times x plus 2. Now we can simply add these things because they have the same denominators. So it's 2 times x plus 2 plus x divided by this very nice common denominator. Voila. Now, we are going to expand this and see what happens. Right? Yes, we are. Okay, so does that fit behind here? I hope so. 2 times x plus 2 times 2 is 4 plus x, right? Once again, divided by our nice common denominator. Here we have something that, like terms that we can put together. 2x plus x is 3x. We have our 4, and I'm not doing anything to the denominator. Okay, so this is what I have, and this is as pretty as it's gonna get. I can't factor out x plus 2 from here, so, and I can't factor out x by itself, so I can't simplify this any further. So this is my single fraction that they asked for, simplified as far as I can. Okay, next type, we're going to subtract algebraic fractions. 3 over x minus 2 minus 4 over x plus 5. Once again, the denominators are not the same, so we need to do something to them so that they will each have a common denominator of this. We can easily get this from here, and we can easily get this by multiplying this by x minus 2. But whatever we do to the bottom to change the denominator, we also do to the top. So here we multiply by x plus 5, so we do that to the top as well. 3 times x plus 5 and x minus 2 times x plus 5. I have to put parentheses around this x minus 2 now, because otherwise we want to multiply this whole denominator by x plus 5. If I don't put the parentheses, we're only multiplying negative 2 by x plus 5, which is not what we should do. Okay, here we multiply both top and bottom by x minus 2, so 4 times x minus 2, and on the bottom x minus 2 times x plus 5, right? Now that we have common denominators, we can simply subtract the top and leave the denominator. 3 times x plus 5 minus 4 times x minus 2 divided by x minus 2 times x plus 5. Then I expand so that we can see what we really have. Let's do that down here. 3 times x plus 3 times 5 is 15. Yeah? Minus 4 times x minus 4 times minus 2 is plus 8. Right? I'm not doing anything to the denominator. There we go. Now we can collect like terms. See, we have a 3x and a negative 4x. That makes a negative 1x or negative x. I have a plus 15 and a plus 8. That's plus 23 all together. And copy down my denominator again. And this is as simple as it gets because I can't factor out an x minus 2 from here. I can also not factor out an x plus 5, so this is just as pretty as it's going to get. And because we don't really like starting the expression with a negative, so you may want to do this and then this, but it's really the same thing, and both of it looks fine. Now, how about an equation involving algebraic fractions? 2x plus 4 divided by x minus 1 equals x plus 4 divided by x minus 2. There's an equal sign, and on each side of the equal sign there's one fraction. That is the situation where you are allowed to cross multiply. You can't do it just whenever you feel like it or don't know what else to do. This is the only time that you can do a cross multiplication. It's an equation, and on either side of the equal sign there's one fraction and not a lot of other stuff added to it. Okay, so we can cross multiply in this case, which gives us 2x plus 4. Need the parentheses because we multiply the entire expression, right? Times x minus 2 equals, let's do that one first, x minus 1 times x plus 4. We expand. 2x times x is 2x squared. The inside term is 4 times x plus 4 times x is plus 4x. Outside, minus 2 times 2x is minus 4x. Last terms, plus 4 times negative 2 is negative 8. Equals x times x is x squared minus 1x minus x. Outside terms plus 4x. Last terms negative 1 times 4 is negative 4. We have some like terms that we can collect here. Plus 4x minus 4x is nothing. So all we have is this. Here we have a plus 4x and a negative x, so that's 3x. Plus 3x minus 4. Now, if we move all these terms over there, subtract them from this side, we'll get a 0, and we have a quadratic form on this side. That'll be nice for finding solutions for x, right? So we subtract x squared from both sides, which leaves us with 1x squared here. We subtract 3x from both sides. There's no 3x here, so no x. So it's just negative 3x here now. So that one's gone. We add 4 to both sides. We have negative 8. We add 4, which gives us negative 4. So we moved all these things over. We subtracted all these terms, so we have 0 left on that side. Stop me if that went too fast, and just make the in-between steps in your own notebook, and you'll figure it out. We are lucky that this is an easy one. We don't need the formula to solve for x, because look, we look for factors of negative 4, which could be negative 4 and 1. It could be 4 and negative 1. It could be 2 and negative 2, or the other way around. and we want a combination of factors that add up to give -3, which would be these two. So I'm going to put a -4 and a +1. So to solve for x, to find the roots of this quadratic equation, either x minus 4 is going to equal 0, or x plus 1 is going to equal 0. If this is true, then x equals 4, right? And if this is true, then x equals -1. And that is the solution for x in this problem. Yay!